Welcome back. This is 11.7 on stability, which is 10.5 in your textbook. We're going to talk about the change of the center of gravity as something falls over. So we're going to look at the idea, will something fall over if you change its center of gravity? Will it remain stable or not? So stability is this idea of will it fall or will it remain where it is? So let's begin by talking about things that can fall over. If something falls over, the reason it falls over is the slightest movement, the slightest displacement that you can make of that object. You're going to have a lower center of gravity, then you're going to fall. It'll be something that you fall. If that center of gravity would be lowered by moving it in any direction, then it's unstable. So imagine standing a pencil on its tip. Okay, I guess it's possible, but I've never seen it done. And the reason why is because if the center of gravity, say, of that pencil is here, and you move it even slightly, okay, it'll rotate on the pivot, and you're going to get the center of gravity lower on this side and also lower on this side. You can imagine like the pencil being here, okay, and its center of gravity is going to lower. That is unstable. So that's kind of the rule of thumb. If the center of gravity would drop by any slight movement in any direction, you are going to have an unstable surface. So something standing on a point, though you could conceive it being done, it would happen in a comic book, would probably never happen in reality because even the slightest wind current could knock it over, lowering its center of gravity, and as such make it unstable, and then it would start gaining momentum and falling. Essentially what you're having is a torque. Remember, this would be the fulcrum, and then you would have the gravity force, which is increasingly acting in this direction as it's pulling it over, and it accelerates over, and that's what you would have. That's unstable equilibrium. The opposite of that is something stable. If something's stable, if you were to move it in any direction, you are going to raise its equilibrium. Okay, so, or center of gravity, raise its center of gravity. Let's say I have a block. The block is on the ground. If I were to pivot it, if I were to try to roll this block over, then I'm going to have to raise it up on this point, and so you're going to end up with a block going in this direction, and you can see that this is going to be moving forward. It's going to be moving up, and for that reason, it will probably stay where it is. You usually will not roll. A block is not going to roll easily, so it's very stable. And you can see that with anything with a wide base. A wide base is going to be stable because you'll have to raise its center of gravity as you move it. A narrow base is going to be unstable because usually it will lower its center of gravity as you move it. I suppose the only other possibility would be that it would be the same. So for instance, if I have a circle, okay, and I move this circle by rolling it, okay, and now the circle is over here, do you see the center of gravity is still going to be in the same place? So if you were to roll a ball, you're not going to have one stable and one unstable. They'll both be stable. This is called neutral. So you're going to have unstable equilibrium as the center of gravity drops. You're going to have stable equilibrium as the center of gravity would have to be raised. Then you would have neutral equilibrium when the center of gravity stays the same. And those are your only three possibilities. So here's an example with a cone. If you were to try to balance a cone on its tip, it probably couldn't be done because you're going to lower the center of gravity. This would be at A. Any change in the position at that fulcrum would lower the gravity, and you're going to have unstable. If you were to put it on its base, any movement of that, other than sideways, if you're going to try to rotate it at all, you're going to raise its center of gravity, and that's probably not going to happen very often, and that's going to be a stable equilibrium. If you were to simply roll it on its side, wherever it rolls to is going to have the same center of gravity, and so that would be a neutral displacement. It doesn't lower or raise the center of gravity at all. So something long and skinny where you have a very high center of gravity but a low base is always going to be unstable. It's possible that you could position a pin on its end so that it would stand up, but it probably would not stand up for a long time because any slight motion, any jar would knock it over. because it has a high center of gravity, it has a narrow support base, and any motion that you would put it in would lower its center of gravity, and that's going to be considered unstable. If you were to raise an obelisk or something high in the air, you would probably have just as much under the ground that's supporting it as above ground. A tree, for instance, doesn't just sit on the ground. It has roots deep into the ground, and so it's actually embedded in the ground rather than sitting on the ground. A telephone pole has to be buried for that same reason, or it would topple over. So the more stable would be the larger base. So look at the first example. If I were to rotate this block, which is standing on its narrow end, okay, it would raise a tiny bit, okay, it would have to be raised a tiny bit, so it is stable, but as soon as it goes that tiny bit, it becomes unstable and then falls. Okay, the second one, since it's on its wide end, would have to be raised a great deal in order for it to become unstable and then topple. This only has to be raised just a tiny bit, this one a lot. So this is the more stable side. And a lot of these is just very intuitive. I could ask someone that's never ever looked at physics and say which one is more stable, which one would not fall over. And just from your experience, you'll know that it's the one on the wide side. Why? Now you know, because you would have to change its center of gravity a long time before it becomes unstable, rather than a short distance before it becomes unstable. If you have a tall tower or a telephone pole or something that's tall and skinny, you need its center of gravity to be low, so low that it's stable. And so what happens is if you're going to have a tower, you're going to have a lot underground. In fact, you probably might going to have more underground than you would above ground. And so that's the only way it would be stable. Otherwise, it would be very unstable. If you were to put something that is unevenly shaped, so that there is a side that has a low center of gravity and one that has a high, objects will always tend towards the low. For instance, an iceberg in the water will always have its heaviest side under the water and its lightest side on top of the water. If you were to have let's say a sphere where you have something heavy like lead and something light like air inside that circle, that ball would immediately turn so that the low center of gravity would be low and the high center of gravity would be high. It's just going to automatically take that shape. So what's your final question? What happens to the center of gravity when an object is toppled? The center of gravity lowers.